Draft Physics video presentation. Last one in the series, responding to What is a Photon by Professor Van Biezen. Like I said, likable guy. Don't even hate the way he teaches, just don't much care for what he's teaching and the lack of distinction between things they actually do know, because experiments confirm it from many different directions and in many ways, and what they imagine things to be. The parts of the model that are solid versus the parts of the model that are, frankly, just made up, and provide less than anything that can be. You can't explain it. You can't sit there and draw a picture of it that's rational. So instead they draw pretty much fake pictures of squiggly lines and things that, a little bit of looking at it you can sort of get the idea that, well, it can't exactly be that. Because they can't draw this field and this ether. And they're unwilling to represent it in some way other than the lines they draw, the model they make. So I'd argue that their models are not very scale, not very to scale, and not very representative of what the actual thing, how it actually functions. So, and I guess I'm just arguing there's a simpler way to model it that works better, that answers more questions and answers them more completely, and that, they should be more willing to engage and defend their model against other potential arrangements of the pieces and descriptions of the event. So anyway, the basic idea here is we're still on the subject of pretty much the atmospheric consequences of global warming, greenhouse effect, and what players there are in that and what molecules. And so it's kind of gotten a little distant from the photon because it's more about what the atoms do to photons. But the basic idea is the energy comes in as momentum, and what happens is that momentum doesn't get where it's going, the shadow, and is absorbed. And by absorbed, it just means that the momentum gives something else momentum, and the something else moves, let's say, a lot slower, or moves in a circular pattern, okay, that doesn't represent any movement in actual space. It's broken its straight line function and converted it into some other line function, and there's always a consequence to that in the universe. When something is going somewhere and it doesn't get there, the place where it doesn't get notices, and then if the object does in some respect change the direction of the force, then the place that's now getting hit notices it's getting hit when it shouldn't be. And so that's really just the distinction. Absorption is just an exchange. You give something else the momentum, and the momentum can move either much slower because it's trapped, or it leaves in some other direction. And so the function of the greenhouse effect would be the energy comes in, it hits the surface, and then gets slowed down or trapped on its way out, which affects the thermal equilibrium of everything on the surface of the Earth. So there's really no need to draw that, right? No.
Welcome to Lecture Online, and now let's talk about photons and the absorption of the photons in the atmosphere due to water vapor in the atmosphere. And it turns out water vapor is the primary reason why the Earth is at a very nice, comfortable climate and temperature, because without water vapor, the average temperature of the Earth would be minus 16 degrees centigrade compared to the average of plus 15 degrees centigrade that it currently is. Now,
and so, but part of this equation is that water likes warm, and so more water will be held the more activity there is in the other molecules. So just one of the facts of the fact that if water likes being in the gaseous state, you could argue. So as you warm water, the water molecules break apart and fly around, and so that's why they're in the air, is because they don't have anywhere else to go. They don't have a quiet place, a cold place to stay. Something like that.
But it turns out that even with the current levels of carbon dioxide, the temperature will be minus 16 degrees centigrade. Water vapor accounts for at least 9% of the heat trapping capability of the atmosphere. And how does...
So you just said even without the CO2, and I would argue that I don't think that's true. One leads to the other. They feed each other. More CO2 means there's more heat, which means there's more likelihood there's going to be water. So it's not just the fact that the CO2 is a greenhouse gas, it's the fact that the CO2 will cause other greenhouse gases to be more prolific.
Does that work? Well, it turns out the water molecule is not a linear molecule, it's a bent molecule. And because of that, because of the shape of the water molecule, it has so many different vibrational modes, each one of them that is able to absorb photons coming back from the Earth. Remember, the reason why the Earth is at this temperature is that the radiation from the Earth, which is, of course, infrared radiation, trying to make it back to space.
So, I mean, the key component of what he's saying there is that it has a molecule that allows them to jitter or wobble or move in a lot of directions. But you could say it's more likely to be moved in the sense that the molecules themselves can end up actually spinning. The group of molecules can spin. They can do lots of things. And all of those things require absorbing momentum. You can't change yours. That is, you can't decelerate or accelerate unless you exchange momentum with something called a photon. That's the way all of them do it. Okay, is they don't really hit each other. They hit the photons, virtual or actual, that the little charges, the electrons and protons, are reflecting to the universe. And so they're absorbing little pieces of momentum, and they absorb them by interacting with them. That is, taking their direction and giving back another direction.
Space has to make it through the atmosphere, and many of the frequencies are being absorbed primarily by the water vapor. The different vibrational modes for water molecules in the atmosphere is what we call the symmetric vibration, which is where the hydrogen molecules can go back and forth like this between the oxygen and the, getting closer and farther away from the oxygen.
Right, and that would be polarizing the atoms actually, so that would be making them, their charge different.
Asymmetric means that it can vibrate like this. Rocking means that the molecule can rock back and forth like this. Scissoring means that the molecule can vibrate back and forth like this. Wagging, the water molecule can vibrate like this. And twisting, meaning the water molecule can vibrate like this. And the combination of all those various ways in which the water molecule can vibrate.
And by vibrate, they don't know there's not some medium that's going to allow them to vibrate. They're only vibrating in the tension they have with each other. So an electron moves. Well, that means it moved closer to another electron over here. And so it's either got to move back, or this one's going to have to move the direction it moved. So it's just about how the momentum transfers. And the fact that water molecules do like to stick to each other means that they're likely to spread their movement between each other. So that's why it's transparent, because it can convey this tip, or it can cause things to spin too far and then spin too far back the other way and do all kinds of other things. But all of them are going to require interactions, and the cause of the interaction can be just thought of as the photon essentially moving through the different movements, the different pieces of movement that was its origin, and eventually it's going to escape. So it's just the fact that the motion is slowed down because it's got to travel a very unstraight path by being transferred between a bunch of different molecules before it eventually comes out somewhere in some new direction.
Allows it to absorb photons of all these various wavelengths. Notice there is a sizable gap between these. And this gap is important because that is the gap through which most of the energy from the Earth makes it back into space. If we go back to the graph that we have here, notice that this is anywhere from about 8.
So it's about a 10 micrometer range of difference. So you got 5.6 to 11 or 12, something like that. So that would only be a 7 micrometers of frequency difference.
Micrometer wavelengths to about 13, 14 micrometer wavelengths. Anything in between primarily gets back into space, and everything to the left and the right of that gets blocked, again, primarily from the water vapor.
So again, you could just argue that it's the same for the transmission of energy through water if you were going to look through it. Certain frequencies go through really easy, visible light, and the rest of them, okay, infrared or ultraviolet, don't get through because the agitation is is inconsistent with the dominoes flipping at the right rate, going back, flipping, going back, flipping, going back, flipping. So if you hit it too fast, then they all tilt, and then you just keep pushing the electrons and creating electricity by moving the actual electrons from one atom to another atom, you could argue. And if it's too slow a rate, then obviously the thing you're moving gets right back to its neutral condition, and you never push anything far enough to transmit. And that's the key to the whole thing, is transmitting. You have to hit it at the right speed to transmit. It's just like there's a set speed for sound in all mediums, and that's basically the transmission speed. And so the transmission speed of water is what you're really seeing in that gap. You're seeing that in that gap, water is transparent. So if you put energy in those frequencies, it's transparent to them, and it'll convey the energy from one side of the molecule to the other side, or one side of the atom, one side of the substance to the other side of the molecules, the group of molecules.
Carbon dioxide does have an effect. Carbon dioxide has a band like right in here where it blocks out all the energy going back into space, and it has another region right here where the carbon dioxide molecule keeps things from going back into space, keeps energy from getting back into space. But notice there's a primary overlap between water vapor and carbon dioxide, so that the carbon dioxide does not add that much heat trapping capability in the atmosphere. It's estimated that carbon dioxide holds back about 3 to 3.3 degrees centigrade of the differential between what it would be if there was no heat trapping gas in it.
Right, but the point is that 3% of the heat on the surface will mean more than just 3% more carbon dioxide and 3% more heat. It's going to mean there's going to be another effect on how many water molecules are in the atmosphere. And as you increase temperature, the curve for how much of the water turns into vapor, the curve isn't some dead straight line. It's one of those, funky lines. And so a little increase in temperature, when you're starting to get warmer and warmer and warmer, you need a smaller and smaller increase in temperature to create more vapor trapped in the atmosphere, because you're making the surface molecules less and less likely to stay liquid.
The atmosphere to what it is today. Again, the primary difference is all the various frequency modes that the water molecule can have. And that's why selectively the various photons coming back up from the Earth get absorbed by water vapor more than any other gas in the atmosphere. And if it wasn't for that, life on Earth would be virtually impossible, because with an average temperature of minus 16 degrees centigrade, life would virtually not exist on the Earth. So we have our pleasant.
So again, another statement. I mean, it's okay for people to say it's really improbable that you could generate complex life forms, blah, blah, blah. But the point is that, yeah, life can live, okay, in pretty extreme conditions. Now, whether it can be created in those extreme conditions is another question. So, I mean, a lot of people could argue that the first living organisms might have been created in volcanic vents, in the saltwater sea. But, they're just guessing. But the fact is, cold isn't conducive to change. And so that would be the argument. You don't have as much activity in cold things. And clearly, activity is part of what makes it possible to create diverse life forms through evolution.
Earth climate the tank to the very interesting capability of the water molecule. And that's how it goes.
So again, yeah, so it wasn't really much on the subject of the photon. It was more about a water molecule. But again, the thing to understand is the difference between transmitting, having a frequency that's the right frequency for the transmission. It's just like in sound, in the sense that vibrations that come, you move too fast, then you're faster than the vibration speed of the dominoes, or whatever you want to call them, their rebound rate. And so you're going to create noise and chaos, and you're going to create deflections in other directions. The force won't be able to go the direction it wants to go, and it'll have to be deflected in some other direction, just like the pressure you push into the earth wants to close in on what you've pushed into. The same kind of effect happens, and so you end up changing the direction of the momentum. And once it starts going sideways, it can go all kinds of other ways, and you end up with scatter. And it takes a while for the scatter energy to get to the surface and leave again as a photon, infrared one, based on just the heat, the amount of vibrations that are being caused by how much energy you do have banging into each other, how much motion you've already absorbed, and motion in different directions. And that's the key to it, is the motions in different directions, which causes a lot of interactions and such. I think that's enough. I've been through some of the more complex interaction stuff, and so I'll just save that for some other video. And so we'll get back to just maybe a general overview kind of video next, maybe, because I haven't done one in a while, and or something like that, or such, and such. So, worth doing, I think. Until the next time. Back to our regularly scheduled videos, responding to what's... There's just so little to respond to. It really is pitiful. You can't find anybody talking physics. The Bill Gates guy is just lost in verbiage and bullshit vocabulary, and there's just no point. It's just playing word games, not really talking theory. And there really just isn't anything else. Professor Lewin has quizzes on art, which is, that's kind of oxymoronic in itself, especially when his taste in art is so, ugh. So anyway, that's probably enough. I don't think there's anything else worth even mentioning. It's so bad. Oh, the Saturday morning science chats are quite hilarious as usual. No, they're really tedious, actually. But the real point is there's people selling theories, but there's no one buying any. And dissidents have a real problem in the sense that they don't have any common ground to build on either. They're just doing rebroken versions of the broken shit conventional physics provides, and they're just all rotten. They're rotten models. They're worse than the bad model they're supposed to be a replacement for, which is really a problem. More complex, more silly, just a fact. All kinds of bullshit about smoke rings being the fundamental function, just stuff that doesn't make any sense. Non-starters, really. So, it's a very difficult atmosphere. And so I'll just have to endeavor to persevere. So that's all I can do for now. The simulations are still in progress. The real catch point is getting the balance between the density of the force and the amount of movement. So it's sort of about how many chunks of quanta does it take to really move an electron in any kind of substantial way. And so that's one of the issues. And the other issue is the motor force, which sort of does require 3 dimensions. But for the sake of the simulation, it'd be nice to be able to do it too. And so that's been a little bit of a sticking point. But anyway, it's It will show up eventually. It's just, yes, the people making the simulations would like them to be complete before they're public, and so more complete. So we're waiting till then. But something soon, I think. Anyway, till next time, and such, and so forth and whatnot. I mean, you don't want a simulation that just mimics it. You want something that derives it, is derived from it. You know, so it'd be a good idea to do it right the first time, and such.